Hello everyone, I am Ramnath Bhaskar. My topic is concurrent connection pool management in Go. I'm going to explain what is concurrency and what is pool and how can we manage those pool using concurrent connection in Go programming. Understanding connection pools. First, what is a pool? Pool is a catch of reusable database connections to reduce overhead. What is reusable database? It's not only database but also reusable resources like other network sockets, etc. Why to use pools? To manage data efficiency and to manage resources effectively. Like with a limited resource, we can use the connection effectively. Without pooling, there will be high latency and redundancy, which would degrade the system stability. Concurrency. What is concurrency? Synchronization of tasks. What is synchronization? Like if there is a chef who is cooking, after cooking, the food can be served to consumers. Without cooking, the food can't be served to consumers. So there will be a synchronization among consumers and chef. Without synchronization, it will not possible. The customers need to wait so long. So concurrency plays a major role in real world problem. Also in programming environment. Channels for concurrency communication. There are two types: buffered and unbuffered. Buffered channels hold data temporarily, whereas unbuffered maintains the synchronization of senders and receivers data. Implementing a concurrent connection pool. First step, initialization, create a pool channel. Then second step, acquiring a connection, create a connection via Go. Then third, finally release the pool. What are the error handling and timeouts? Error handling and timeouts, why it is necessary? Because there may be a deadlock problem or some other problem. The error handling should be maintained and timeouts between each task should be maintained so that there will not be occurrence of deadlocks. What are the performance and scalability? The scalability and performance are much more comparing to procedural, because implementing concurrency would be much efficient than procedural programming. What is the conclusion and best practices? I would rather prefer concurrency rather than procedural, because concurrency benefits in more thing, and Go routines has simple lightweight threads. So Go concurrent would be much better than other concurrency. Leak prevention, monitor and optimize to maintain connection health. Using logging and metrics to track pool performance continuously would be much better. Then my problem statement is to write a Go program that uses a mock database connection pool and use multiple tasks to access the mock database and use Go routine pool and Go routine concurrency to manage it efficiently. What is my aim? To design and implement a concurrent connection pool using the Go programming language that efficiently manages and reuses the limited mock database connection across multiple Go routines. What is the workflow? Start, initialize connection pool, set up concurrency, then task. What are the tasks? How many tasks? Get connection from the pool, use the connection, return connection to the pool, then the task will be completed. Initialize connection pool. Initialize connection pool. Define a struct mock connection to stimulate a database connection. Create a connection pool struct with a buffered channel to hold a fixed number of reusable connection. For example, in my program I take 3 connections. Then define a worker function which would has the task ID. Then set up concurrency. For example, the tasks might be 10. Create a sync wait group to track the completion of concurrent tasks. Then start Go routine for workers. Wait for all tasks to complete using wg.wait. Then complete execution. Once all tasks are completed, the message will be shown. Then the code. Initially package main, the package main is the starting point of the program. Then what are the import statements? fmt math underscore rand sync time. These are the inputs that require fmt for printing, math.random for a random time allocation, sync for synchronization, and time for waiting. Then next step, create a mock database connection structure. Type mock connection id int, only single field id which is of int type I have created. Then create a connection function. Then create new connection pool that initializes pools with n connection. For example, in main function I have passed that random using random function I have get a random time, and I initialized pool size is 3 and number of tasks is 10. The 10 tasks is split within the 3 pools. Pool is equal to new connection pool of pool size. The pool size will be passed up here. Then this will make use of those pools and create pool connection, 3 pool size of connection. Then using wait group, I will allocate a wait time. Then I have initialized tasks to 10 tasks is initialized. For the 10 tasks the worker function will work, and randomly the tasks will be finished within a wait. Then after finally all tasks are completed, now I will run the program. See, the same code is here. First go to the particular folder. Then run the main function. See, as you see that only 3 connection is made used. Randomly task 2, task 10, task 5 is using 1, 3, 2 connections, and one of the task will be finished after this. Then randomly task 6 is using connection 2. Then task 2 has been finished. Task 7 is using connection 1. Within these 3 connections, it efficiently switches over and finishes its tasks. And finally, after completing all tasks completed messages will occur. Thank you.